Welcome back. In this class, we are going to see the other forms of CMOS logic in detail. I'm going to start with the first one. What is the first one? A pseudo Nmos logic. Okay, this is the general circuit diagram of a pseudo Nmos logic. If you observe that in this pseudo Nmos logic, you are having a PMOS transistor, okay, which the gate terminal is connected to ground, and you are having an NMOS network. It is not an NMOS transistor. Once again I am telling that it is an NMOS network. Okay, we are going to give inputs for this network. Okay, now you can observe that depending upon the inputs, this network is going to be evaluated and you are having an output. Is it clear, all of you? Okay, now just you can observe that why this is known as pseudo Nmos. Can anybody try to tell? Is there any speciality for this to tell the name as pseudo Nmos? Yeah, absolutely. Why? Because when the gate terminal of PMOS transistor is connected to ground, you can observe that it is looking like what? Absolutely, it is looking like a depletion mode NMOS. Is it clear? Okay, therefore here it is looking like a depletion mode NMOS, and the evaluation logic is also an NMOS network. Therefore it is totally looking like an NMOS network. Therefore it is called as pseudo. That means pseudo in no sense here duplicate. Okay, therefore it is referred as pseudo NMOS logic. Is it understood? Now you can observe very importantly how to design any boolean function using this one. Okay, first of all let me explain. If the inputs are n number of inputs, if the inputs are n number of inputs, then how many transistors are required? The number of transistors required to implement the logic is equals to, anybody? Inputs are n, you are having one PMOS, therefore n plus 1 number of transistors are required. Is it understood? Okay, that is an important point you have to remember, and you can observe very clearly. Okay, you can observe very clearly. If I want to design an inverter, then what should I have to do? Can anybody try to tell? If I want to design an inverter, what should I have to do? Absolutely. Is it clear? Since inverter consists of only one input, I require only one NMOS network along with the pull-up device. What is a pull-up device? A PMOS where the gate is connected to ground. Okay, and you required an NMOS. This you are having a V in, and this is VSS, and this is VDD, and you can have a Y, that is an output. If you want, you may cross check the operation here. When Vin is equals to 0, this will be in off condition, and since PMOS is connected to ground, that means the gate terminal of PMOS is connected to ground, it is always in on condition. Therefore what is an output at the Y terminal? The output is equals to VDD. I hope that are clear. Now you know very well that PMOS transistor will pass strong 1, therefore the output is no doubt about it, that is 1. Is it understood? And similarly, if you observe that when Vin is equals to 1, okay, now you can tell me that when Vin is equals to 1, what is happening there? Okay, when Vin is equals to 1, you can observe very carefully. When Vin is 1, this transistor will turns on, and don't forget this is also in the on position. Therefore there is a path for output to reach ground. Is it clear, all of you? Therefore the output is generally, that means ideally we can tell it is a 0, that means VSS, but don't forget this is in on condition. Therefore some of the voltage is going to be appear at Y, therefore the output never reaches to 0. Is it clear? The same problem you are having, that means non-zero output. And a very danger thing here is, now you can observe what is the danger thing here is, when Vin is equals to 1, you can observe one more time. When Vin is equals to 1, okay, you can observe one more time. I will use some other color. When Vin is equals to 1, this is in on condition and this is also in on condition, therefore there is a static power dissipation from VDD to VSS. I hope that are you clear, all of you. That is an important thing you have to remember. What is the first drawback? The output never reaches to 0. What is the second drawback? Absolutely, when Vin is equals to 1, that means all the inputs of an NMOS network is equals to 1, then there is a static power dissipation from VDD to VSS. Why? Because there is a path from VDD to VSS which leads to static power dissipation. I hope that are you clear. In your examination point of view, let us consider they said to design Y is equals to AB plus C whole complement using pseudo Nmos logic. Okay, now how to design this? Don't forget the pull up won't be changed. What is a pull up? This is a pull up. Okay, now you can observe this is a pull up. Now I will use some other color to design pull down. Now you know very well AB is there. Okay, in AND or NAND, Nmos should be in series. Are you clear? This will be A and this will be B and C should be in parallel. Then it should be what? C. Now it is connected to VSS and it is connected to VDD. Now output, you can take the output between pull up and pull down network. Is it clear, all of you? Okay, now you can observe that how many inputs are there? A, B, C. That means how many transistors are there? 3 plus 1. That means 4 transistors are there. I hope that are clear. In this way you can able to design any Boolean expression using pseudo Nmos. I will show one more thing. Let us consider they said to design Y is equals to A plus B plus C. Okay, don't forget there is no complement here. Okay, therefore you should have an inverter. Now you should have a pull-up network here like this. And how many inputs are there? 3 inputs are there. Therefore 3 should be in parallel. 1, 2, 3, and commonly connected to ground. This. Let us consider A, B. I will write some more clearly. Otherwise, I will use different color to represent it. B. Okay, C, same color I have used. Okay, now don't forget it is connected to ground. That is an important point, and the output is taken here. But don't forget it is not your output. You have to design an inverter here with a pseudo Nmos. Now this should be connected to ground and it should be your input. This is VSS and this is VDD. I hope that are clear. Now this is connected to like this. The output of the first network is connected as input to the second network. Then if you take an output, then it becomes Y. I hope that are clear. Is it understood? When there is no complement, then very important point is you have to tell n plus 1 inputs, sorry, n plus 1 transistors. Okay, I will write some other way, with some other color. Okay, you can observe that n plus 1 transistors you required and followed by one inverter. That is an important point you have to talk about. Is it understood? That means now will you please tell me what is the drawback? What are the drawback present here? Absolutely. What are the drawbacks? Non-zero output. Non-zero output is the drawback. And second one, when all inputs are equals to 1, then what is happening? Absolutely. What is happening? Danger symbol. That's why I am writing with the red one. Static power dissipation. Okay. Now what is the advantage of this one? Advantage, you can talk about advantage. Absolutely less number of transistors, required compared to CMOS. How many number of transistors required? N plus 1 number of transistors required. I hope that are you clear. That's it guys for today's class. In the next class we will see another CMOS alternate gate circuits. Is it clear? That means other form of CMOS we will continue. Is it okay? Thank you very much. Have a nice day.